Okay, guys, welcome. Here we are again. This is Properties of Logarithms video number 1. Properties of Logarithms video number 1. All right, so we are going to talk about the properties of logarithms today. And the properties of logarithms are very important, and we're going to use these when we start solving some more equations. Okay, and so properties of logarithms. We've already talked about what a basic logarithm represents, and we talked about the fact that they were exponents. And so they have some properties and some rules that are very similar to those exponent properties. And so they are related. I won't go into great detail about them, but these 4 properties that are listed here are going to be very important. Okay, we're going to go through just quickly each one and look at how we can use these. And so property number 1 relates to the product rule. And it basically tells me that when I have 2 logs, and I can do log base B or log base A, but say I had log base 2 of, say, 3x plus log base 2 of, say, 5, I can rewrite that as log base 2 of 15x. I'm able to actually multiply the things that are on the inside. And so that gets me from taking 2 logs and rewriting it as 1 log. That's the product rule. The quotient rule does basically the same thing. It gives me the ability to take log base 3 of, say, 21x minus log base 3 of 7 and rewrite that as log base 3 of 21x over 7, and then I can reduce that, and so that could become log base 3 of 3x. So these properties, this subtraction can be rewritten as a division, and this addition over here can be written as a multiplication. That's what the properties of logs tell me here. Now, the biggest one, or the most important one, or not necessarily, they're all important, but one of the best ones is number 3. If I have a log base 2 of, say, x to the 4th, this property lets me take the 4 and put it in front as a multiplier. And so that becomes 4 times log base 2 of x. And that's going to be real important. That's going to be real important in the future, because multiplying, I can divide to cancel out if I want to, but when we get to solving, that's going to be real important. And then the last one. This one is just a real common sense. This one's called the one-to-one property. I didn't write that down for whatever reason. This is called the one-to-one property, and it basically says if you have log base A of something is equal to log base A of something else, you can ignore the logs. You can just drop them and just focus on those 2. And we've kind of done that. We did this one-to-one property when we solved exponent equations, and so that one is going to come into play as well. Okay, so now what we do with these is we expand and condense our properties, our logarithms, to do this. Now I've got 2 expands, which we don't do a whole lot with expand because it's not as user friendly, but we do a lot with condense. So I have a lot more examples of condense than I have with just the expand. But here's how this one would work. If you notice in this expression here that I have a times and another times, and up here in rule 1 I have a times, so I can take a times and rewrite it as a plus. So that's what I'm going to do. So this I'm going to rewrite as log base A of 6 plus log base A of x to the 4th plus log base A of 1. And so I have expanded this, and I can take it one more step because of this rule right here. This rule deals with a power. So I can take that 4 and put it right there. And then copy down the rest of them, just like I had before. And again, handwriting is important. That A is smaller and lower, and everything else is regular sized. But that's the answer to that one right there. I expanded that one. So now I've got to make myself some room over here. This one, again, remember, this is log base E. Okay, this one's going to be a little bit fancier in just a second. E to the 4th over 11. Okay, so now we're going to use log base E because that's important to us. So this one, there's a rule that says division can be turned into subtraction. And so this division is fixing to become subtraction. So this one is going to look like this. Log base E of E to the 4th minus log base E of 11. Okay. Now, this other little thing, the same one we did a minute ago with the little 4, with the little exponent, rule 3, property 3, okay, where we take the exponent and it goes in the front. So this exponent is going to go to the front. So this is going to be 4 log base E of E minus log base E of 11. And some of you are like, there's 2 E's there. Is that the way it's supposed to be? Well, yes and no. Yes, it's correct, but if we go back to the foundational meaning of what a log means, we're going to be able to find that this is equal to 1. Just this. Let's just take this one piece right here, okay, and let's think about that. I'm going to move it all the way up to the top here so that we can look at it. I'm going to erase this actually so we can look at it. You can come back and add your little notes later. Oops, touch something I didn't mean to touch. I'll put it back. There's 11. Okay, so let's look at this. This says log base E of E. Let's just think about this. Remember what I told you this said. The log means what exponent. That's what log means. And then the base, it says what exponent turns E into E. What exponent turns E into E? Well, that would be 1. Log base E of E is 1. This is very important. That's 1. It's almost like a canceling out thing. Yeah, we're going to get there. So this is really, for the answer here, that's a 1. So that's 4 times 1, which is 4. Now, can I do the same thing with that other one? No. What exponent turns E to an 11? That's some crazy psychotic decimal I've never met before. I didn't pull my calculator out. But I can put it back in the LN notation because that is the fancier, more appropriate notation. So for that one, that's my final answer for that one.